The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has managed to observe places that are around 13 billion light-years away. But recently, James Webb has outdone itself. It spotted something it wasn't supposed to see. Astronomers using the telescope have detected a supermassive black hole from when our universe was less than 600 million years old. Just a baby. This discovery is the most distant, actively feeding supermassive black ever observed. It's located at the heart of its host galaxy, designated Sears 1019. The black hole is also one of the smallest and least massive ones found in the early universe. It's equal to approximately 9 million suns. It might seem like a lot, but in reality, supermassive black holes often grow to billions of times the mass of our star. But what is so unusual about this find, and why are scientists having a hard time trying to explain it? You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. It happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.5 million times the mass of our sun, are supposed to be seen in the more recent universe. Well, to tell you the truth, scientists have long suspected that supermassive black holes could have existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It has shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust falling inside them. Such swirls are also called accretion disks. The gravitational force of a black hole heats this matter, which makes the disk shine bright like a diamond. Sorry, but that's not all. Strong magnetic fields produced in the process channel the matter to the poles of the black hole, and from time to time this matter is blasted out of there in twin powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. By the way, astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Synth survey. They saw the galaxy as it was when the universe, which is around 13.8 billion years old now, was a mere 570 million years old. Besides the main character of this video, scientists spotted two other black holes. Those probably appeared 1 in 1.1 billion years after the Big Bang, and 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. The coolest thing about all these discoveries is that until recently, all research about things that existed in the early universe was mostly theoretical. But now, with the help of the James Webb Telescope, astronomers can not only see galaxies and black holes at unimaginable distances, but they can also measure them. This isn't the only discovery connected with black holes made recently. For example, not so long ago, scientists saw two stars slow down in their orbits around black holes and concluded it was most likely the result of drag produced by dark matter. It was the first time astronomers might have discovered some indirect evidence that huge amounts of dark matter could surround black holes. Now, about that dark matter. What is it, and what does it consist of? Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Since it's such a small fraction of the universe, maybe we shouldn't call it normal? Dark energy takes up around 68%, and about 27% of the universe is dark matter. This dark matter is just one more space thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. This matter is dark, so we can rule out visible stars and planets. It also can't be dark clouds of normal matter. Otherwise, scientists would be able to detect it. Dark matter is not antimatter, since astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. In other words, dark matter is still as much of a mystery to us as dark energy. Anyway, back to the potential dark matter discovered around the black holes. If it is confirmed, it'll be a great breakthrough in dark matter research. What helped scientists come up with this idea is that dark matter interacts gravitationally, influencing ordinary matter. So, a team of researchers watched the orbits of two stars decay by about 1 millisecond per year, while they were circling their companion black holes. The scientists concluded that these changes in speed were the result of dark matter generating friction and a drag on the stars. With the help of computer simulations of the black hole systems, the team tested a model widely known in cosmology. It's called the dark matter dynamic friction model, and it predicts a certain loss of momentum by objects that are gravitationally interacting with dark matter. And guess what? The simulation matched these predictions. The results of this research helped to confirm a theory that had existed for a long time, that black holes can actually swallow dark matter that comes too close. As a result, dark matter gets redistributed around black holes, creating areas with different densities, which can influence the orbits of surrounding objects, like the stars we've been talking about. Speaking of black holes, there's a theory that primordial black holes could actually be dark matter. This type of black hole is hypothetical since scientists have never got any real proof of their existence. Such holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. If primordial black holes indeed existed, they could appear because in some regions of space, it was hotter, other regions were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though, these holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. Anyway, the idea of the connection between primordial black holes and dark matter, or rather, the idea of them being the same thing, remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think, and it means that the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
And we'll start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So, what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. Sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere, and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus the strongest ones, X-class flares, have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
If the sun decided to stop producing light, then the animals in the wild would be the first to notice. Most animals need daytime to roam from place to place, especially in the large savannas in Africa. Zebras, wildebeests, and giraffes all need the day to move to avoid predators. As soon as the sun goes down, it's their bedtime. If the sun suddenly went dark, animals wouldn't comprehend what was going on and would simply become an early lunch for predators. Nocturnal creatures would be equally confused at the time change. Birds usually flock during the day, so we wouldn't hear or see any of them. We have them to thank for eating pests in the sky. Well, them and bats. But if you're in an area with no bats, then consider the insects to be the winners here. Temperatures would start to drop gradually. Humans would notice the effects as well. We're used to having the sun shining at the peak of noon, but with the sunshine's disappearance, we would be living in total darkness. It'd just be a matter of survival. If the sun suddenly got dark, then we'd only have around 8 minutes to enjoy the rest of it. That's because it takes that much time for sunlight to travel thousands of miles across the solar system. We would have to use UV lights to grow some crops, but it wouldn't be enough to feed the whole world, not to mention the dropping temperatures across the world. Survival would be difficult in the open plain. Everyone would have to duck inside shelters and warm bunkers. Plants need photosynthesis to grow. Without it, we wouldn't have any crops. Bread wouldn't exist, since it needs wheat. Even the algae in the oceans need photosynthesis to survive, which is the highest source of oxygen rather than forests. This means oxygen levels would start to deplete. Large bodies of water like lakes, oceans, and seas would also start to lack oxygen to sustain marine life. One of our main sources of vitamin D is the sun. There are other ways of getting it, but the sun is the best and most convenient way. Without crops or vegetation, all the herbivores would have to rummage for the last green grass on land or a leaf hanging from a tree. They would soon run out of food, which would also be bad news for us humans, since we need animals like cows, horses, and sheep for our livelihoods. This wouldn't happen overnight. Of course, the oceans would remain warm for some time, but eventually, they would get cold and freeze. Earth is still a planet powered by an iron core that produces so much heat. This would not be enough to keep the planet warm. Our next step would be finding the right shelter and keeping warm. If this happened overnight, then chances are there wouldn't be any ready-made bunkers for a scenario like this, unless you're watching this video and decide to build one after. They would have to provide heat 24/7 and be capable of growing crops under UV light. Solar-powered facilities would be a thing of the past. People would have to wear sustainable suits when venturing out into the open. Since it would be so dark, we would need strong lights or powerful night vision goggles to see anything. The lands would be desolate. Nocturnal creatures that can handle freezing temperatures would take it over. Structures would collapse, since there would be oxygen depletion. Concrete needs oxygen to remain intact. The bunkers themselves would have limited oxygen as well. We would need to uproot many trees and place them under strong UV lights for them to produce oxygen. In turn, it would produce its ecosystem in the large underground bunkers. The oceans on the surface would freeze over eventually. Gathering any natural resources from the ocean floor, like gas or oil, would be impossible. The large object, which used to be a bright and sunny star, would still be floating around. But what would happen if the sun disappeared overnight? Well, pretty much the same thing, except way worse. The sun is the largest celestial object in our solar system, which keeps all of our planets lined up the way they are. They orbit around the sun, minding their own business. Without such a large object keeping them steady, the planets would start to float around randomly. Some might even collide with each other. In other cases, the planets would just float around and fly off into space eventually, until they found a new star to orbit around. Earth might or might not be one of those planets. Our planet would still be dark. We would be flying through space at an unusual speed. The planet wouldn't rotate on itself, and many objects would crash into us. We'd be in the trajectory line of mass comets waiting to strike us down. The threat of the cold wouldn't be a major factor anymore. It would be what's beyond us. This means we'd have to dig our bunkers deeper. We wouldn't have an atmosphere anymore to trap any form of heat or anything. We would be floating for an eternity. But let's go back to that scenario where the sun just decided to go dark. Don't worry, our planet would still be orbiting the sun along with the other planets. The temperatures would keep plummeting until nothing could survive on the surface. It would be total darkness 24/7. Only bacteria and possibly tardigrades could survive on the surface. Tardigrades are microscopic critters that can survive just about anything, including outer space. Eventually, oxygen would be absent from the Earth's surface, and there wouldn't be anything up there anymore except for them. Since they would be the dominant and possibly the only creatures on the surface, they'd manage to evolve into bigger species and produce many more. Hundreds of thousands of years into the future, humans would have had to evolve to the conditions underground. Our eyes would be much bigger to take up as much light as possible. Our skin would become whiter since there would be no sun underground. Our hearing would also be much more sensitive since the underground would create echoing sounds. We'd still have the intellect we do now, but our bodies would be ready for the surface. The main threat would be the giant tardigrades sluggishly dragging themselves around. Under a microscope, they look kind of cute, but imagine them the size of a polar bear. Still want something like this in your backyard? They can live anywhere, so they'd infiltrate the bunkers now and then. They'd get ferocious and come in different sizes and shapes. At this point, humans would not be the dominant species, since they'd have to hide underground. Some tardigrades from different tribes wouldn't be friendly with each other. Major cities that used to be bustling with people would be home to giant water bears. Tardigrades are known as water bears since they kind of look like little bears, but these beasts with 8 legs would be much bigger than them. Bears and most animals would have been wiped out on the surface. Under the ice, some deep-sea creatures would thrive and have moved closer to the surface. These animals were used to living in darkness away from the sun, but over thousands of years of dominating the waters, they'd have grown to enormous sizes. Some of these creatures would adapt to crawling out of the mainland. Even though the surface would be frozen, they'd still find ways to crack through the ice and make their way. Humans, meanwhile, would create large underground channels and networks, building cities and colonies. We'd dominate the tunnels where our hands and feet would grow to become web-like and large. We'd take over everything underground and remain the smartest species on Earth. We'd manage to keep old art pieces from the surface and important records to stay as human as possible. We'd keep on surviving no matter what.
The snow-capped shape of Mount Taranaki in the middle of Egmont National Park in New Zealand is surrounded by a dense, dark-colored forest. It creates a gloomy green circle around the area. From above, the circle looks almost perfect. But it's only because of the local farmers. They use all the fertile soil they can, and it results in a contrasting color scheme. A near-perfect cone volcano, a rare geological phenomenon, has occasionally been erupting for over 100,000 years. It grew taller and larger after every eruption. It's predicted that in about 50 years, this volcano could turn the area around it into another Pompeii. In Italy, there's a unique spot known as the Giant Pink Bunny. You can find this humongous art project on the green fields of the Coleto Fava Mountain in northern Italy. The 200-foot-long and 20-foot-high bunny appeared in 2005. It was created by the art group Gelatin from Vienna. Not only does it have a strange and unique design, but it's also knitted. It took the team 5 years to finish the delicate structure. It used to be just like any other stuffed toy. Visitors could climb the bunny, taking in the views around them. But since it was placed on the hills, the art piece has started decaying. After all, it was only meant to last 20 years at the most. The once bright pink bunny has turned gray and has almost disappeared. If you look at the Google Maps satellite images these days, you might only notice its outline. While not as popular as Old Faithful, the Grand Prismatic Spring in Yellowstone Park, Wyoming is one of the most spectacular sights to see even from ground level. But from above, The bright bands of orange, yellow, and green really start showing their beauty. It's one of the biggest springs in the world, larger than a football field at 370 feet across. The hot water in it travels 121 feet to the surface. The spring is a feeding ground for heat-loving bacteria that change their color in the cooler water. A director searching for an unusual area for filming discovered a mysterious floating island in northeastern Argentina. Almost perfectly round and surrounded by a dark forest, it gives you an eerie feeling. No wonder the place got nicknamed the Eye. With the help of time-lapses on Google Earth, it was discovered that the inner landmass was moving around rather than sitting still as was first believed. A circle of land 387 feet in diameter, ranging from several inches to many feet in thickness, casually floats in the clear waters. It even rotates slowly, pushed by the cold water from below. This water is still being studied. It's completely exclusive to the surrounding area. From above, it looks like nothing more than a little island sitting in Homebush Bay, Australia. But zooming in will change that perspective. Once a successful trading port, the bay is filled with 4 abandoned cargo freighters that were too hard to remove. Once they became decommissioned, they were left in the bay and forgotten. The shipwrecked SS Airfield transformed from a broken-down wreck into a small but beautiful nature reserve. It's filled with thriving mango trees that have overtaken the ship and are slowly breaking down its hull. In the Gobi Desert, in the northeast part of China, bizarre symbols appeared in certain areas. This led to many theories of what they could be. Maybe ancient markings like the Nazca lines found in Peru. Guesses range from odd weather patterns and pipelines for some future development to target practice areas, but it turned out to be none of those. They're simply special symbols used to calibrate the cameras on China's satellites. The Badlands Guardian in Walsh, Canada, is one of the most famous and fascinating spots you can find on Google Earth. It looks like a man's head carved into the landscape. A feather headpiece that Native Americans used to wear sits on top of the head. It must be quite a modern design because the face also seems to have a pair of earphones. Unfortunately, it's just a simple road with an oil rig at the end. From ground level, the entire thing is not nearly as impressive. It looks just like any other exposed rock face that's been changed by the seasons. But this phenomenon is nothing more than the pareidolia effect, the same that makes you see objects in the clouds. An island on a lake, on an island in a lake, on an island is surely a mouthful. But Google Earth beautifully captured the place. A tiny island named Vulcan Point sits inside a crater lake on an island called Volcano Island inside a lake called Lake Tull on the Philippine islands of Luzon. It's one of the only 2 lakes in the world that have been discovered to have a third-order island in them. Tull Volcano is still active, and because of the large lake inside the crater, there's a risk of a volcanic tsunami. It can be triggered by debris falling into the lake after an eruption. This might create waves in the lake that can spill over the sides of the crater. The Firefox crop circle appeared in a cornfield in Oregon in 2006, but it wasn't some mystery or rare phenomenon. Celebrating the browser's 50 millionth download, the Linux users group from the Oregon State University created the giant logo. It was larger than 45,000 square feet. The group members stomped down all the stocks in a near-perfect circle. It was completed in under 24 hours after 2 careful weeks of planning. The final circle had a diameter of over 200 feet and was completely invisible from the road. It could only be appreciated from the sky. The most beautiful bright blue ponds are found at the Intrepid Potash Mine near Moab, Utah. Most potash forms in desert regions where inland seas or lakes dry out. As the water evaporates, it leaves behind potassium salt deposits. Most evaporation ponds are more reddish in color, but some dye was added to these particular ones. Dark water absorbs more sunlight and heat, speeding up the evaporation process. This leaves behind the salts much more quickly. stunning aerial views of these ponds are a bonus. Making the largest advertising logo on Earth is something every marketing agency would dream of doing. And Coca-Cola did just that in 1986. The logo is an extremely large sculpture. It can only be viewed in its entirety from the sky. The biggest problem about such advertising, though, is that barely anyone knows about it. This huge Coke ad is 160 feet tall and 394 feet wide. It was built from 70,000 empty Coke bottles in northern Chile's Arica. The gigantic monument was created to celebrate the brand's 100-year anniversary. A guitar of this size can only be appreciated from extremely high above. The unusual shaped forest is located south of Cordoba in the Pampa region of Argentina. Known as the Guitar Forest, it extends for more than half a mile. It also contains more than 7,000 cypress and eucalyptus trees. A 74-year-old Argentine farmer, with the help of his children, managed to transform this piece of land into something magical, all done to pay tribute to his beloved wife. From high above, this area seems to be just a collection of boulders in the middle of a lake, but this is actually Hippo Pool in Tanzania. Hippos are common in all the rivers in the area, but this spot is certainly the best in the Serengeti to watch them playing around. The animals there swim in large groups of about 200 hippos. They stir up the waters and fill every square inch of space inside. If you can't get to Tanzania to see the spectacle, Google Earth gives you the opportunity to have this experience in the safety of your home. There are many large-sized pools in the world, and then there's the pool at San Alfonso del Mar, a resort outside of Santiago, Chile. Officially, the world's largest pool ever created. It cost nearly $2 billion to build. The pool is roughly the size of about 16 football fields. The water for the pool is taken from the Pacific Ocean. It gets filtered and treated multiple times a day to keep the gigantic pool clean. There's a saltwater pool inside a large glass pyramid, if you want to swim in a pool inside a pool. I'm getting confused. A strange and mysterious swirling pattern appeared in the desert of Egypt back in 1997. When this design was first discovered on Google Earth, it created a bit of a stir of what it could be. That was until it turned out to be nothing more than a giant art installation called Desert Breath. Two intertwining spirals are complete opposites. One spiral is piles of sand that are shaped like cones, and the other is made of mini craters. When the installation was first completed, the spirals led to the center of a circular pool of water. But since then, the water has dried out. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops, well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Dark, ever-hungry monsters live all across the universe. They're born when massive stars blast into space. Black holes as heavy as Earth are just as large as a ping-pong ball. They don't have a surface, but their gravity is so strong even light can't escape it. Black holes don't have physical boundaries like a membrane either. The event horizon, which is closest to a typical boundary, is a threshold which, after passing, you can't get out. For a star, running into a black hole normally ends in a spectacular light show and its destruction. Just one star that astronomers know of managed to survive an encounter with a black hole as heavy as 400,000 suns. It happened in a galaxy about 250 million light-years away from Earth. Astronomers with really powerful equipment noticed bursts of X-rays that raged in space every 9 hours. They thought they must be Mayday signals from a star trapped by a cosmic abyss. The star was an average red giant when it met its new friend for the first time. When they got too close to each other, the hungry space monster couldn't resist the temptation and snacked on its guest. When it was done with the star's outer hydrogen layers, all that was left was the star's core. Eventually, the poor thing turned into a white dwarf. But for some reason, the giant space monster couldn't finish the meal and trapped it in its orbit for later instead. Ever since, the now white dwarf has been traveling in 9-hour laps. It stays far enough from the hole so it won't fall in or get swallowed. Its journey isn't going super smoothly. Because of gravity, the orbital path is constantly rotating. After 2 days, it resembles a spirograph pattern. As the black hole keeps snacking on it, the star keeps losing its mass and growing in size. Its own orbit is becoming more and more circular. Scientists believe one day it will be able to spiral away from its mean friend and turn into a planet the size of Jupiter in 1 trillion years. That's 70 times longer than the universe has existed so far, so it might not ever happen. The Milky Way alone has hundreds of millions of black holes, and there are way more beyond it. They might feed on other stars and release them in other galaxies. The telescopes that exist now might not be strong enough to spot them. Most galaxies, including our Milky Way, have supermassive black holes at the center. They can be billions of times heavier than the Sun. Others of their kind are only 3 times the mass of the Sun. The nearest black hole to the Earth was spotted 1,000 light-years away, just around the corner in galactic terms. It's in a star system you can see with an unaided eye. Scientists found it when they noticed a star behaving weirdly. It was a giant, rotating like crazy. They guessed it must have a powerful gravitational companion. The hungriest black hole astronomers have spotted so far weighs as much as 34 billion suns and is about 6 times bigger than the one at the center of the Milky Way. It eats the equivalent of 1 sun every day. Sometimes black holes even devour others of their kind that happen to be too close to them. Before you get on a spaceship to escape to some safe, no black hole galaxy, here's some good news. Even though they're supermassive, they don't have a radius large enough to destroy Earth. And even the hungriest of them are safe to watch from a distance. No black hole should come closer to our planet than the Sun for as long as the universe has existed, multiplied by 10 billion times. In the unlikely case one of these scary things passes by Neptune, it could affect the Earth's orbit. That would be no good. In theory, anything can turn into a black hole. The only difference between it and the Sun is the material their centers are made of. It's incredibly dense in those huge space monsters. In reality, there's just one known way to make a black hole. It has to be the gravitational collapse of a supermassive star, 20 to 30 times the mass of the Sun. So, the Sun will never ever become a black hole. If it happened, though, and the former star retained its mass, it would still have the same gravitational power. Earth would still keep going around it and wouldn't get pulled in. Its orbit would also remain as it is. The only huge problem would be the lack of sunlight. In reality, the Sun isn't massive enough for such a transformation and will eventually become a white dwarf. A black hole won't ever eat an entire galaxy for lunch. There are about 400 billion stars inside the Milky Way. Just around 0.1% of all the stars that will ever form will end up becoming black holes. The ever-hungry supermassive monster, located right in the middle of a galaxy, has an impressive gravitational reach. But even that wouldn't be enough. It has already eaten most of the stars that were close to it. It already weighs like a few million suns, so it can't grow much larger even if it keeps snacking on sun-like stars. Galaxies will keep bumping into each other, and black holes will keep growing and merging. But because the universe is already huge and keeps expanding, these collisions and mergers won't go on forever. Black holes will travel this huge space like rogue stars. They won't even be able to eat the dark matter on the outskirts of galaxies. Eventually, all the black holes will perish, but that would be a long, long time from now. If you ever become a space explorer and travel far enough to meet a black hole and fall into one, your life won't instantly end. Instead, things will be way more complicated. The way you perceive space and time will change, and your reality will split in two. In one of them, you'd cease existing. In the other, you'd live and enter the hole unharmed. When you go deeper inside the hole, you'll notice space becoming curvier and curvier. At the center of the hole, it's infinitely curved. It's called singularity. Laws of physics based on the ideas of space and time don't have power here. In a large enough hole, millions of times more massive than the Sun, things would go perfectly smoothly for you. And you just keep free-falling, feeling no gravity. You could just keep falling and falling in total emptiness until you reach singularity. You'd have no chance to move in the opposite direction. In there, space and time switch roles. Time is constantly pulling you forward on Earth, but figuratively, and it would be doing that quite physically inside the hole. In a smaller hole, the force of gravity would be stronger at your feet than your head. That's why you would go through spaghettification. This is how scientists call the process when you compress horizontally and stretch vertically like spaghetti because of crazy gravity of the black hole. Speaking of spaghetti, how are black holes like an Italian dinner? Because once you go pasta the event horizon, you get spaghettified, and since you're all by yourself, you'd be feeling cannelloni right now. Wow, now I'm hungry. Meanwhile, if you had a fellow space traveler who, for some reason, didn't end up in the black hole, it would look all different to them. They'd see you stretch and grow, like through a huge magnifying glass. The closer you get to the edge of the hole, the more it would seem like you're moving in slow motion. Then you'd freeze, and the flames would surround you. You'd be in two places at the same time, living different destinies, but there would still be just one copy of you. This is how black holes teach us nothing is real. Reality can be different to different people. Some scientists believe that we're all living inside a huge black hole. Everything in the universe started with the Big Bang. But there's a theory saying there was also something before that. It was a super dense seed that had all the mass and energy of the universe concentrated in it, about as heavy as 1 billion suns. It was 1 trillion times smaller than any particle humans can observe. This seed could be born inside a black hole. If you believe there's more than one universe, black holes could also serve as doors between those universes. It could be like a root that two trees share. You can't see a black hole directly because it doesn't give off any light. Scientists used to be able to only spot them by what they were doing to their surroundings. When over 200 scientists around the world worked together, they managed to take the first pictures of that space oddity. The equipment they used, added together, would be the power of a telescope the size of Earth.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our Sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the moon. The Earth takes 365 days to orbit around the star. At the same time, the moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the moon passes through it. The shadow is cone-shaped and gradually narrows. The moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the moon. When the moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the moon during a total lunar eclipse, planet Earth would be exactly between you and the sun. So you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the sun's corona illuminating the edges of the planet. The Earth from the surface of the moon is almost the same size as the moon from the surface of the Earth. Such a red eclipse of the moon is rare because several factors must coincide. One of them is that the moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses, and the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides. Its gravity seems to draw water to it from the Earth's surface. The sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be 2 mountains, one on the moon's side and one on the sun's side. And as the moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the moon is attracting water to itself by about 4 to 6 inches. The moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the sun. But the moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the moon. The gravitational force there is 6 times less than on Earth. So, if the average person on our planet weighed about 180 pounds, on the surface of the moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the moon. Here on Earth, the average person could lift about 130 pounds, but on the moon, you could raise a big motorcycle or a grizzly bear. The surface of the moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, about 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, the spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the moon. There's no atmosphere on the moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the moon is in question. The moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns you to orbit. You dock with the ship and return to Earth. Sounds like some pretty great plans for a week's vacation. Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded It was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive, though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip. We're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So let's keep exploring and keep being amazed by the wonders of the universe.
What can survive in space? Well, people can, if they have an excellent spacesuit. Spacesuits are, shall we say, kind of a needed item in the vacuum of space. Without one, you'll have to stay inside the spaceship or modular dwelling on the Moon or Mars. Currently, NASA has only several older spacesuits ready for use outside the spacecraft, like the International Space Station. NASA's Artemis mission to the Moon is planning to have new suits designed for both men and women. It has a $250 million budget for them. These new suits are much less bulky than the older ones and much more fashionable. But what other creatures besides people can live in space? 3 named animals were sent into space, and they all came home safely. Does that qualify? 2 dogs, Belka and Strelka, spent a day inside a Russian spacecraft in 1960 and became media stars upon their return. The USA launched a chimp named Ham on a 16-minute ride into space. Space starts 62 miles above the ocean level and only takes a rocket a few minutes to get there. Ham, who wore a spacesuit, performed all his button-pushing tasks admirably and is honored in the International Space Hall of Fame in Alamogordo, New Mexico. But tardigrades can actually live in space. Tardigrades, or water bears as they are often called, are brown and look like teeny tiny grizzly bears, and are one of the most miniature animals with legs. They have 8 of them. Most species of tardigrades have no eyes, but some do. It's possible to see water bears with a good magnifying glass, since they average about a ½ millimeter in size. Sprinkle a little water on moss and they'll come out. They can walk about 1 body length per second and run at about 2 body lengths per second. Water bear eggs are easier to spot because they're bright white. The European Space Agency took water bears to the International Space Station and left them outside for 10 days. They survived. They still survived with no air, water, almost a perfect vacuum, harmful solar radiation, extreme cold, and heat. Well, that doesn't sound very fun, does it? In extreme conditions, water bears rely on their exoskeleton, or tun, to protect themselves. In laboratory tests, this exoskeleton could withstand immense pressure at over 87,000 pounds per square inch. That's quite a spacesuit they got. Water bears have even been frozen solid for 30 years, and when warmed up, the water bears revived and were still able to reproduce. As we search for life in space, as we explore Mars, these types of extreme life forms become essential to understand. If water bears can survive literally every environmental condition, can we conclude that life is everywhere in space? Extremophiles are life forms living in extreme conditions, such as other planets might have. Mobile Cave in the country of Romania is one such place that could just well be on another planet. All life on Earth, on the surface of the Earth, is carbon-based. It means that carbon atoms act much like a universal Lego block, to which hydrogen, oxygen, and nitrogen atoms connect to form the molecules that the cells of living organisms are made of. But not in Mobile Cave. Mobile Cave was sealed off at least 2.5 million years ago. The water that percolates up through limestone rock has formed a lake in the cave, a mix of hydrogen sulfide, poisonous and corrosive, and ammonia. What could live in this toxic soup? Well, sulfur-based life forms. An entire ecological system without light or photosynthesis exists inside Mobile Cave. The food chain is built on chemosynthesis, microorganisms eating sulfur-based chemicals. 33 species of sulfur-based creatures were found living in the hostile environment of Mobile Cave. Shrimp, scorpions, centipedes, snails, etc., etc. Mobile Cave is an alien world deep underground full of sulfur-based life forms. If creatures like this exist in Mobile Cave on Earth, what can we expect to find living in outer space? Bacteria. Bacteria can live in outer space, and fungi too. Bacteria form the base of the food chain, and bacteria have been proven to be able to live in outer space. In the 1980s, cosmonauts on the Mir space station complained that something was growing outside the station's windows and blocking their view of Earth. It turned out, upon inspection, to be bacteria and fungus, or fungi. The windows, made of quartz, were being damaged and weakened by what was growing on the surface. Fungi were also found to be eating copper on some of the cables. Mold was found growing in some places on the outside of Mir. The space station was under attack by microorganisms. Scientists took this very seriously and began to investigate. It seems that in a sterile environment such as space, bacteria come out of their hiding places when no other microorganisms are around. Cosmic radiation may even help them mutate and adapt to the space environment. The bacteria seem to be growing even faster in space than on Earth. Years later, the United States decided to run a bacterial experiment on the International Space Station. They coated rocks with various bacteria and put them outside the space station. Some bacteria did not survive the harsh conditions of space, but many did. One strain called OU-20 survived for over a year and a half outside the ISS. Japan also did a bacterial experiment on the International Space Station. Outside the Japanese Kibo module, Kibo's robotic arm placed 3 panels with the bacteria Deinococcus radiodurans, or D. radiodurans for short. It survived outside in space for 3 years. The lead scientists of the Japanese experiment calculated that the bacteria could live as long as 8 years in space. That's long enough to make a journey to Mars and back 4 times. Now, this raises a couple of interesting questions. Could life have come to Earth from Mars in a space rock? And, more pointedly, could an infectious bacteria come to Earth in a space rock? Suddenly, what had only been considered in science fiction books and movies was now a subject of intense scientific scrutiny. And then came the Mars meteor. Antarctica is the best place to find meteors because it's covered by ice. The ice in the Allen Hills regions of Antarctica is locked in place by the configuration of the surrounding mountain. The ice here sublimes. That means the ice evaporates, never becoming liquid but turning directly into vapor. As the ice in the Allen Hills region sublimes, it exposes all the meteors that have hit the ice over many hundreds or thousands of years. Meteor hunters literally drive around on snowmobiles and pick them up with tongs, never touching them to avoid contaminating them with human bacteria. They bag the meteors, number them, and record the location and any other pertinent facts about the meteor. That's how meteor ALH 84001 was found, the Mars meteor. Since Earth gets hit by about 17 meteors every day, over thousands of years the numbers add up. Almost everywhere has been hit by a meteor at one time or another. 11 years apart, 2 houses on the same street in Weathersfield, Connecticut, had their roofs punctured by 1-pound meteors. But only a rare few meteors ever come from Mars. 126 meteors have now been identified as coming from the red planet. ALH 84001 came from Mars. Scientists know this because the United States has landed on Mars and sampled Martian rocks and the Martian atmosphere composition. ALH 84001 contained the same gases as Mars' atmosphere and similar chemical composition as the rocks. But the meteor also contained something else, a fossilized life form. There has been much debate about whether or not the tiny object inside ALH 84001 is a fossilized bacterial life form, or rather a chemical deposit. But the studies aboard the International Space Station confirm that bacteria can live for a long duration in space. So it is entirely possible that some bacteria could make the journey to Earth from Mars in a meteor. The United States Mars Exploring Perseverance rover has recently found organic molecules inside Mars rocks. These organics are carbon and hydrogen. It won't be known if these organic molecules were produced by living organisms or merely by chemical reactions until the samples are returned to Earth sometime before 2030. The search for life on Mars is ongoing. But Mars is not the only place in the solar system that might have life. Jupiter's moon, Europa, is a good suspect too. Entirely covered by miles of thick water ice, Europa may have an ocean of salty water beneath its icy crust. Ice acts as an insulation blanket. Combined with possible internal thermal processes in Europa's core, means that Europa's ocean water could be warm. The Europa Clipper Express mission plans to confirm conditions for life on Europa. Loaded with 9 pieces of observational equipment, the Europa Clipper will attempt to observe just about everything possibly going on by orbiting above Europa, including the chemical composition of the mysterious reddish-colored material that has ejected onto the surface ice from the ocean below. What could this reddish material be? Could it be a specific chemical mix? Or could it be krill, shrimp, fish, life forms like in Moville Cave? Or the ancient remnants of a Brightside narrator? Stay tuned. Attention, attention! Something very exciting is going on Saturn. It's called a spoke season. And no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are two smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that.
You've been training for this for years. You know you're ready. You're standing on the door's threshold. You take a deep breath and bravely open it. You jump outside the International Space Station and into the vastness of space. Ah, this never gets old, you say on the transmitter device. You feel like a feather whenever moving through space. Except for the suit, of course. It's true what that guy told you one day. Astronaut suits limit your body's movement by 20%. For you, that means you've got a 20% higher chance of being clumsy in outer space, which is never good odds. There's not a lot of room for error during a spacewalk. You finally get to the docking port. You look around and see the part of the station that needs fixing. This is where other space shuttles dock when they come in from Earth or other planets. About a week ago, a shuttle coming from Jupiter miscalculated the landing and broke a piece of the port. You've attached the new shield to your suit's belt. Now all you've got to do is screw it on the station. You've spent hours training underwater to do this. You wore a heavy, hot, uncomfortable suit inside a pool in order to get the training you needed. Incoming! Sarah shouts on the transmitter. You don't even have time to ask what, as an absurdly fast storm of space debris catches you off guard. It shakes everything around you. You try to hold on tight to the strap that's keeping you safe, but oh no! A piece of debris just hit your helmet shield. Come in, Bob, are you okay? Sarah asks you through the radio. You got a bit shocked by the impact, but everything seems fine. The meteorites are finally gone, so you can focus on your task now. You pull the rope that's connecting the new docking shield closer to your body, but the other part of the rope has nothing on it. Zip. Nada. Oh my, you think to yourself. Come in, Sarah. We have a lost shield. I repeat, we have a lost shield. This is a pretty serious situation, and you are aware of it. Anything that falls into space can go into a collision route with the International Space Station or with other space vehicles. You try to remember your training, but your mind goes blank. This is worse than that one time you broke your girlfriend's favorite ceramic jar. Sarah, the other astronaut who's with you on the ship, is shouting words on the transmitter. "Oh no, Bob. Tell me you didn't do this. This is a total catastrophe. I'm coming outside." You spot the shield under the ISS. It's the size of a medium-sized car door, and it's moving quite fast. Here's what can happen in this scenario. The shield could head back down to Earth and break into the atmosphere. It would probably catch fire and disintegrate on the way down, but anyways, it would make NASA and you look pretty bad. The other option is the car door-sized shield gains momentum, and it orbits all the way to hit the ISS, and you for that matter, or some satellite that happens to be in a similar orbit. Here's the thing. If you ever thought that space was an infinite void, you got that part wrong. Since different countries started to build equipment strong enough to travel in space, space has been more crowded than ever. Not with people, but with satellites, asteroids, and space debris. You were surprised when you learned that Earth receives meteorite showers every single day, but they're so small that no one on the surface of the planet notices it. They usually turn to ashes before hitting the ground, but that's not all. What just happened to you on this mission has happened on several other missions before. Astronauts keep losing stuff in outer space. So much so that NASA had to create a division to track down and monitor the orbit of all debris that is just floating carelessly around. You couldn't believe it when someone told you that there are over 23,000 softball-sized pieces of debris roaming around in space. And if we're talking about smaller objects, then that number goes up to 500,000. As you were about to unstrap yourself and dangerously venture through outer space without any protection, you notice Sarah has beat you to it. You can't let her do this alone, so you decide to tag along. FYI, this is against every NASA handbook and training you ever received in your life. But you think, if this works in sci-fi movies, it must work for us. Even though we all know that's very far from the truth. Sarah's close to the debris shield, but her body weight makes her orbit in a completely different direction. Okay, you think to yourself, this is your turn to shine and be a hero. You try moving your arms like you would do underwater, but there's no friction in space. Duh. You can't butterfly swim your way to rescue the rogue equipment. You try to contact Sarah, but she doesn't come in. I guess you're on your own now. For some reason, you start to orbit in a similar route as the floating car door shield. It must be the amount of stuff you've got strapped onto yourself. Or maybe it was the breakfast burrito you had that morning. You feel like you're George Clooney in the movie Gravity. No, better yet, you feel like Obi-Wan Kenobi. Yes, you're feeling as strong and powerful as a Jedi right now. You keep your hands stretched before your body, hoping you'll gently collide with the space debris. And 3, 2, 1, and the landing was successful. Just joking, but yes, you managed to dock onto the debris. Hooray. Now what? You think? Guess you needed to have gone through that plan of yours a little bit more, huh? You still have no way of steering the debris. And now, you have no way to contact Mission Control and tell them the object, and yourself, are en route to somewhere. Don't get scared. You didn't come this far to get scared. What's the best thing you can do? First, take a mental picture of the Earth. It never disappoints from up here. Then, you try to play out the possible scenarios that could happen in the situationship you're in. Your normal body weight would not be enough to get you out of Earth's orbit. In the hypothetical scenario in which this did happen, you'd probably be vacuumed into Venus's orbit and spend a quite unpleasant period of your life around immense heat. Even though in Greek mythology, Venus represents love, there is nothing lovely about orbiting close to this planet, and you know this. If you got too close, your spacesuit would never be able to take on the heat. It's only made to sustain temperatures of around 250 degrees Fahrenheit tops, and Venus's atmosphere can heat up to 700 degrees Fahrenheit. But honestly, the worst-case scenario is much simpler than that. Your spacesuit could decide to drown your ears, nose, and mouth in water. Yup. This has happened on spacewalks before yours. You see, in order to keep your spacesuit chill and cool, the suit relies on a gallon's worth of water that makes up for a cooling system. This system, which is supposed to send recycled air into the back of your helmet, does leak sometimes. And since you're stranded in the middle of the big nowhere, you'd have only that nowhere to run. But wait, what's that popping up on the horizon? It's a modular space shuttle. You try shouting, but nobody can hear you outside your helmet. You wave with your hands, but it's coming straight at you. Finally, it took longer than I wished to find you, Sarah said. Apparently, she made it back to the space station just in time to catch you before you went definitely rogue. Guess I'll be losing some astronaut points for this little misadventure, huh? You say. And yes, you definitely will.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or